Welcome back to section 4.8. We're going to be talking about some applications. A lot of this you've seen in geometry and so forth. So we're going to be talking about solving right triangles, finding all the missing sides and all of the missing angles. Don't forget, when you find angles, you use the inverses. You use the arc, sine, or sine inverse, arc, cosine, cosine inverse, and the arc tangent or the tangent inverse. That's how you find those angle measures. All right, so in problem 1, what we need to do is we need to find the measure of angle B. We need to find the length of segment A and the length of segment C. Now we can find angle B the easiest because the acute angles in a right triangle are complementary. So angle B is going to be 90 minus 34.2. So we're going to get 55.8 degrees. Now, the length of segment A. Segment A, we have the opposite and we have the adjacent. We don't have the hypotenuse. So the only one that doesn't use the hypotenuse is tangent. So what we can do is we can do tangent of 34.2 equals opposite leg, which is A, over the adjacent, which is 19.4. So we put the tangent 34.2 over 1 and we cross multiply. So A equals 19.4 times the tangent of 34.2. Make sure you're in degrees for your mode. And you're going to get about 13.18. Now we need to find angle C. So what we can do is side C. We're looking for the hypotenuse. We can either use sine or cosine. I'm going to use 19.4 because that was given to us. So what we can do is cosine of 34.2, and that's going to equal the adjacent 19.4 over the hypotenuse C. Put that over 1, and we cross multiply. C times the cosine of 34.2 equals 19.4, and divide both sides by the cosine of 34.2. So C equals, and when you divide, make sure you're in degrees still, 23.46. And there we go. We found all of the missing sides and all of the missing angles. Problem number 2. Safety regulations state the maximum angle of elevation is 72 degrees. The longest ladder they have is 110 feet. So let's make a quick sketch. Here's the building. The ladder is 110 feet. That's the hypotenuse. And the angle of elevation is at the bottom. We're looking up to the top of the building. So we need to find the maximum height, which is this value there. So we have the hypotenuse, we can use sine or cosine. So we could do sine 72 equals opposite, which is x, over the hypotenuse 110. Put it over 1 and cross multiply. X equals 110 times the sine of 72. So x equals about 104.6. So about 104.6 feet is the safe height that it could reach. That's the maximum height, safe height. All right, let's go to the next page. Like I said, this is all review. We've done this before. Now they're going to get a little bit more challenging here for problem number 3 and 4. So for number 3, at a point 200 feet from the base of the building, the angle of elevation to the bottom of a smokestack is 35 degrees. The angle of elevation to the top is 53 degrees. We want to find the height of just the smokestack. So here, I'm going to draw a quick sketch. Here's our building, and here is our smokestack. We want to find this value, the height. Now, we want to break this into different pieces. So if I look, we're here at the bottom. The angle of elevation from the ground to the bottom of the stack is 35 degrees. So that angle is 35 degrees. So we can use that to find the height of the building. We'll call that Y1. We can also use then the 53-degree angle to find the height of the building and the stack. We'll call that big distance Y2. So I'm going to break it down to its smaller pieces. What we have, here's our 35 degree, here's 200, and we'll call this Y1. So we don't have the hypotenuse. We don't care about the hypotenuse. Let's use tangent of 35 equals opposite Y1 over 200. Put that over 1, cross multiply, Y sub 1 equals 200 tangent 35. So Y1 equals about 140.04 feet. For the bigger triangle, here's Y2. This is 53 degrees, and this is still 200 feet. So the tangent of 53 now equals Y2 over 200. When we cross multiply, Y sub 2 equals 200 tangent 53. So Y sub 2 equals about 265.41 feet. Now we only want to find the stack height. So we're going to take the big distance. So the height would be Y2 minus Y1. The total distance minus just the height of the building. So it's going to be 265.41 minus 140.04. So the height is about 125.37 feet. Okay, let's go to problem number 4 now. Now we have a swimming pool. It's 20 meters long and 12 meters wide. Now we're just going to be looking at the cross section of the pool. Now the bottom of the pool is slanted. It goes down. So the depth in the shallow end is 1.3 meters, and in the deep end is 4 meters. We want to find the angle of depression of the bottom of the pool. So here is a cross section of the pool. We know it's 20 meters long. Now the shallow end is 1.3 meters, and the deep end is 4 meters. Slants. What we want to do is we want to find the angle of depression, and that's going to be up here. That's theta. It's that angle from the shallow end to the deep end. So if you notice, at the bottom we have a triangle, and it's a right triangle. I'm going to unclutter the picture a little bit. I'm just going to draw the triangle portion. Here's theta. Here's our 20 meters. Here's our right angle. Now, the difference in height is this is 1.3 meters. So we can do 4 minus 1.3, which is 2.7. 2.7 meters is the depth of that pool from the shallow end to the deep end. So now we just want to find the angle. We don't have the hypotenuse or care about the hypotenuse. So what we have is we're going to use tangent. So the tangent of theta equals opposite 2.7 over 20. Now to find the angle measure, we have to use the inverse tangent. So we're going to take the tangent inverse of both sides, or the arctangent of both sides. So we're going to get theta equals, and the arctangent of 2.7 over 20 is 7.7. Make sure you're in degrees. 7.7 degrees. There's our angle of depression. We're going to skip the next page and go to problem number 6. The sonar of a Navy cruiser detects a submarine that is 4,000 feet from the cruiser. So here we are on the top of the ocean, and the sub is down here. Now it's finding the total distance, the direct distance, is about 4,000 feet away. Now the angle from the water line, here's the water line up here, that's 34 degrees. That's that angle of depression. We want to find the depth of the sub. We want to find x. So once again, we have the hypotenuse. We have the opposite. We can use tangent. The tangent of 34 equals opposite, which is x, over hypotenuse of 4,000. Oh, sorry, not tangent. Opposite over hypotenuse is the sine. Excuse me. So x equals 4,000 sine of 34. So x equals about 2,236.8 feet, or 2,036.9 feet. That would be the depth of the sub from the surface of the ocean. Problem number 7. The sun is 25 degrees above the horizon. Here's our horizon line. We have a silo here casting a shadow 50 feet. So if I connect with a triangle, now it's 25 degrees above the horizon. That 25 degrees, that's at our angle of elevation. Sorry, the silo, is 50 feet high. We want to find out the length of the shadow. We want to find that there. Now for this one, this time we do not have the hypotenuse. So without the hypotenuse, we'd want to use tangent. Now, if this angle is 25, I can actually find this angle by 90 minus 25 equals 65. You don't have to do this, but this is a little bit of a quicker way to do it. Because opposite over adjacent is tangent. Now, if x is in the denominator, it's a little bit more work to solve. If x is in the numerator, it makes it easier. So what we can do is tangent of 65 equals opposite, which is x over 50. Cross multiply, x equals 50 tangent 65. So x equals about 107.2 feet. So the shadow is about 107.2 feet long. Number 8, a ladder leaning against the side of the house. The ladder is 20 feet. That's the hypotenuse. Angle of elevation is down here 80 degrees, and we want to find out the height that the ladder reaches, h. We have the hypotenuse. We're going to use sine or cosine since we have the opposite. Sine of 80 equals h over 20. So h equals 20 sine of 80. H equals about 19.7 feet. It's a little bit of an aggressive angle. I don't know if I would use an 80-degree angle in a house, but just a math problem. All right, last one. The length of a shadow of a tree is 125 feet. Angle of elevation is 33 degrees. Angle of elevation here to the top of the tree, 33 degrees. Now the shadow, this horizontal distance is 125. We need to find the height of the tree. We can call it x. Once again, we don't have the hypotenuse. We can use tangent. So tangent, opposite over adjacent. So let's use that 33-degree angle. X over 125. So x equals 125 tangent 33. So x equals about 81.2 feet. That's the height of the tree. Okay. That is it for this part. There'll be another video going over problem number 5, talking about trigonometry and bearings. Okay, thank you, and I will see you in the next video.